All right, welcome. Let me switch to the camera mode. Sorry. Welcome. This is the lecture for Monday, the 30th of March. And what I'm going to do is, this is going to be fairly brief. I'm just going to describe the practice test that I've posted on Blackboard for you to do today. And then on Wednesday, we'll go over that test in great detail. We're not going to take the test until the 13th of April. So you're good. You've got a full 2 weeks. Full 2 weeks and maybe a day or two. And so not to worry. You'll be very prepared to take it. I think I am going to set it up as an online test, so that so all you have to do is go on the Blackboard, click the link, start taking the test, and you'll have a certain amount of time to take the test, and then it will end, and you'll be the test will be submitted automatically, and there will be extra time for any folks that have disability services. Okay, so with that, let me talk about the things that'll be on the test then. Okay, so let me shrink this. Shrink that. No, that's not what I want to do. I want to shrink it. Okay, there we go. And then let me kind of go over. I went over one of the tests the other day. Let me first off, let me show you what that's going to look like. So here you are, spring 2020, the Blackboard for logic design, and so let's see. So again, the videos are here, the quizzes associated with the lecture are here, the reflections here. I won't do a quiz with this. Well, maybe I'll just do a real simple one where you have to say, yes, I took the you can say, yes, I did the practice exam. Okay. And maybe I'll have you say how long it took you to do it. Okay. So anyway, here's practice test 2 for S20. That's it right there. You just click on that and it opens up, and it's going to look like one of the standard tests that we've done. We'll show it to you here in a second. So it looks like this. And so the first problem is going to be this truth table problem. And you're going to have to figure out whether the SOP form or the POS form is simpler, or maybe they're exactly equivalent. And you have to write out the midterms in notation. So you just the numbers of the midterms. Number the squares, 0, 1, and so forth in the little bitty squares. Remember, AB's on the top, CD's down the side. So it's 0, 1, 2, 3, and so forth. Remember to flip both the rows and the bottom 2 rows and the rightmost 2 columns. Then put all the ones in the correct squares. Don't put in the zeros. I think it's just distracting. You can put the zeros in down here. There are no don't cares, so that's good or bad. Either way, there aren't any don't cares. Then I want you to loop all the prime implicants, and be very careful to try and get all the prime implicants. Don't miss any. And then I want you to evaluate it you can evaluate the SOP solution up here and the POS solution down there. Figure out which one is going to be simpler. You should be able to just look at the K-map and determine which one is going to be simpler. Because once you identify the best solution, then you should be able to you should be able to compare those and see which one's going to have more terms or terms with more literals in them. All right, then the next problem, realize 4 switching functions using this read-only memory. Here's the ROM. And so you have to, here are the 4 functions, F1 with these midterms, F2 with these midterms, F3 with these midterms, F4 with those midterms. You have to fill out the truth table, just put in the ones, don't put the zeros in. Same over here. And then you have to map from your truth table into your ROM. You also have to map in, you have to connect the correct signals to the address lines. Notice the address lines here, there are 4 of them, A3, A2, A1, A0. So you have to make sure you get the right signals hooked up. I'll just give you a hint. A3 is the higher order address line, and A is the higher order variable, input variable. So normally you would think that you'd want to connect A to A3. Just a little bit of a hint. Here are the outputs. Now, you can fill this in however you want. You could put the address lines however you want. But if you want to be able to map this in the easiest way possible from the truth table into the ROM, obviously you want to preserve the hierarchy of the addresses and you want to preserve the outputs. So you would typically probably want output 0, O0, to be F1 and so forth. Anyway, so you need to fill in the correct outputs down here, the correct signals here, and then you need to put the information from the truth table needs to go in the ROM so that when you address a particular row, the right values for the functions come out the output lines. Now, one of the questions is how many bits in this ROM? Well, so that's pretty easy to figure out. Each one of these squares is a bit, right? And I don't think I screwed this one up. One time I had one too many. Let me see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Yes, there are 16 boxes in every column, 4 columns. So that should be pretty easy to figure out. All right, so I'll leave that to your devices, but this is how you do it with the ROM. So remember, we've now looked at 3 ways, 3 devices we can implement functions with: a ROM, a multiplexer, and a 3-to-8 decoder or a decoder of some size. All right, here's a flip-flop. So how would you turn this into a D flip-flop? We've been over this. So you have to modify the inputs with a gate here, or with an inverter or something, or maybe just connect them together, whatever. How would you turn it into a D flip-flop? What kind of clock does it have? Notice it's got a little bubble here and a caret. Does it have a set or a clear? Well, looks like it's got a little something there. Is it active, high, or low? Well, is there a bubble on that input? And then, so what kind of clock does it have? How does this flip-flop have a set input shown? Is the asynchronous clear active high or active low? Circle the answer. All right, given a switching function G, draw with gates how to realize it in 2 layers. Then show how you would modify the expression to implement it with gates having only 2 inputs maximum. So obviously to implement it in 2 layers, you'd have a couple of input OR gates and 1 output AND gate. And these gates would have 4 inputs each. And the output gate would have 2 inputs. How would you then implement it in this case, probably 3 layers, but with gates having only 2 inputs maximum? Since these aren't NORs or NANDs, this is fairly straightforward to do. Hazards. So in dealing with hazards, we have some true-false questions. And then down here we have we have this expression, AC plus BC plus BDC prime plus A prime B prime C prime. Is that C prime? Yeah, C prime. So what you have to do, we want you to fill in just the shorthand notation for all the minterms. So what minterms are contained in this expression? Well, the way you figure that out is you just go ahead and plot it in a K-map. So first you plot AC, then you plot BDC prime, then you plot A prime, B prime, C prime. And when you do that, you will then have all the ones plotted over here. Now, some of these terms are going to overlap with other terms, so you don't want to get too confused here. Let's see, let me blow it up a little bit so it's easier to see. Yes, it is C prime. So anyway, when you plot those, you're going to have some ones in your you're going to have some ones on your truth table. Now remember, there may be places where these overlap. So if that's the case, then you don't count them twice or anything. You just put ones wherever they're indicated, and then you just write all the ones out, all the minterms out here in this shorthand notation. All right. And then starting in this SOP form, put it in a form that would represent a 2-layer net using NaN layers. All right, so now you have to take this expression, invert it 2 times, partially expand the inversion, and with the first partial expansion, you should have it in NaN form. All right, final question is this flip-flop here. What kind of flip-flop is it? Well, it's a JK, right? Does it have a rising edge clock or a falling edge clock? Well, there's no bubble, so that should tell you. So the first thing you would do is you go through and mark all the active edges. Yeah. Does it have a set or a clear asynchronous input? No, it does not. So this is a little bit easier problem. So you don't have to worry about the asynchronous inputs. You just have to worry about J and K. So mark all the active edges, and then at every active edge indicate the value of J when the edge hits and the value of K when the edge hits. And then remember that there's no actual change in Q, assuming that it's supposed to change, until 10 nanoseconds after the edge of the clock. So obviously the change on Q does not happen synchronously with the edge of the clock. It's delayed a little bit, okay? And so make sure you account for that 10 nanosecond delay and then draw in Q. And so for instance, this would be the active edge. It's a rising edge because there's no bubble. And so J would be 0, K would be 1. Well, what's going to happen? That's going to be a situation where it's going to stay cleared. It's going to stay in a 0 state. So Q starts out 0. It's going to stay 0, so that's going to continue, and nothing can happen until this edge. What's going to happen at this edge? Well, J is 1 and K is 1. So what is it going to do? Well, you should know in a JK flip-flop, if they're both 0, it holds. If they're both 1, it toggles. If J is 1 and K is 0, it sets. If J is 0 and K is 1, then it clears. So armed with that information, you should be able to solve this problem quite easily. And that's all there is to it. All right, so that's the test. I want you to do it. You don't have to submit it, but I will post a key. I'll post a key probably tomorrow morning sometime, or sometime tomorrow probably, or maybe late tonight. But I'd like you to have a chance to work on it before I put the key out. Okay. So I'm going to get rid of this. Okay. Now, so that's the main thing I want you to do today. And then we'll go over that very carefully. When I actually give you the test on the 13th of April, I will make it an online test. So it's going to have to be a little different. And I'm not quite sure just how that's going to work. But anyway, I haven't made that test up yet. But it'll be the same type of problems. It's just that the format of the test will not be where you're writing on K-maps and things like that. So I'll give you a K-map, say, and then you'll have to. What I'll probably do is have a document that you refer to, and then the online part of the test, you can look at the document, and that'll show you the figure that you need to look at, and then you can type in the answer on the online part of the test. I don't know. We'll see. We'll make it workable though. Same information, slightly different format for testing. So that's just how it's going to be. I'm sorry, but that way I won't get the, Dr. Morton, I tried to upload my test, but it was 12:01 and I was supposed to upload it by 11:59, and I'm emailing it to you instead, and whatever. This way it's just online. Do it, and you'll have. I'll probably just give you a relatively short. Well, probably just give you a relatively short window to take the test in. Maybe like. Well, I don't know. I'll probably give you an hour to take the test, and you'll be able to take the test. Maybe any time that day. but I might have everybody take the test about the same time. I don't know. I haven't really thought about it. It's we like everybody to do their own work is the bottom line. Okay, all right. So I think that's really all I pretty much wanted to cover. Remember, I will have another session. I think maybe Wednesday morning at about noon. I think I'll have a session and I'll send you an invitation. I'll have a session to invite everybody to a little Zoom meeting where we can talk through things. I only had 4 people last time, so I really would expect 110 people. That would be great. So there are a bunch of you not engaging in this process, and how am I going to give you a grade if you don't do anything? So if send me an email if you have, if there's some reason why you can't engage in this process. But I really encourage you to get involved, to show up for this question and answer session on Wednesday at noon. Okay? All right. So there'll be a very short quiz after this lecture for you to take. It'll be an online quiz. There will be a time frame. You have to get it done by, say, midnight tonight. And then the link goes away. If you don't get it done, then, that's fine. But, it will count a little bit. I'm not going to count these quizzes heavily, but I'm going to count them some because they tell me that you're watching the videos and working on the course. And all right. So hang in there. If you're really having a hard time, send me a text. Let me know. My cell phone's on the Blackboard, of course. Or send me an email. Or you can reach out to TAs. I can't think of what else. I think that's just about it. All right. So if any of you are really struggling, do send me a text and let me know. We can get you help. There's also the university is making an ability to log on virtually so that you can have the same engineering image we have on all the lab computers on your laptop or desktop, and that would work even if you have a Mac. So keep that in mind. I don't know. It may not apply. It doesn't really apply to logic design because we're not doing many labs in this. But anyway, if that's an issue, let me know. All right. Good talking. Hang in there. Stay safe. Continue to do your social distancing. This will eventually pass. Not sure how long, but eventually.